In this video, we will look at solving trigonometric equations. We will do this by looking at several equations and solving them, and doing these examples, we will then begin to see techniques for solving these types of equations. We begin by looking at cosine theta is equal to 1/2, and we want all possible exact solutions. Begin by just drawing a unit circle. Now, where is cosine positive? That is going to be in either quadrant 1 or quadrant 4. If we look first at quadrant 1, we want to know what angle gives us 1/2 when we take the cosine. Well, that is pi over 3. Now remember, cosine is 2 pi periodic. So not only will pi over 3 give us that, but add 2 pi to it will also give us 1/2. Add 4 pi, or take away 2 pi, so on and so forth. So all of the solutions involving pi over 3 will be in this form. If we come down here, what angle? Well, this is an angle of 5 pi over 3. And so theta 2 would be 5 pi over 3 plus 2n pi, where n is any integer. Now, oftentimes, we're going to be given a specific domain to look at, as in this example. We wish to solve this equation only within the range here of 0 to 2 pi. Now again, typically, we want to go ahead and draw a unit circle first. That is a terrible looking unit circle. That's better. Now let's go ahead and solve for cosine of theta here. Begin by adding 3. Now divide by 2, and we find that cosine theta is equal to negative 1/2. Cosine is negative in quadrant 2 and quadrant 3. Now, where is it? Negative? I'm sorry, it's not negative 1/2. It's negative 1. My apologies. So this is wrong. Cosine will be negative 1 right here on the x-axis. That corresponds to the angle of pi. Now we look at this equation. Now again, notice the domain is 0 to 2 pi. We first solve for sine. So we add 1, divide by 2. Now we take the square root of both sides. So we'll have the absolute value of sine theta is equal to 1 over the square root of 2, which is root 2 over 2. Now what this says is that sine of theta is root 2 over 2, or sine of theta is negative root 2 over 2. So we again look at our unit circle. Sine is positive in the top 2 quadrants, negative in the bottom 2 quadrants. So for the positive, we're going to be somewhere in the top 2 quadrants, right up here. And those angles will be pi over 4 or 3 pi over 4. For negative root 2 over 2, we're down here in the bottom 2 quadrants. And those angles would be 5 pi over 4 and 7 pi over 4. So our solution's set. Pi over 4 3 pi over 4, 5 pi over 4, 7 pi over 4. Now we wish to solve this one, and again, notice that we're dealing with 0 to 2 pi. Now we want tangent theta minus pi over 2 is equal to 1. Well, let's go ahead and look at the unit circle. Tangent is positive here in quadrant 1 and down here in quadrant 3. That's going to be important. Now, where is tangent going to be 1? Right? Well, it's either going to be at pi over 4 or at 5 pi over 4. Right? So theta minus pi over 2 is pi over 4, or theta minus pi over 2 is 5 pi over 4. Solving the first one, we get theta's pi over 4 plus pi over 2. That is 3 pi over 4. Or theta is 5 over 4 plus pi over 2, and that is 7 pi over 4. And so we have the solution set, 3 pi over 4 or 7 pi over 4. We wish to use technology to solve this equation, and again, notice that we're looking for 0 to 2 pi. Now, before we use the technology, we want to analyze this a little bit. Now let's again draw our unit circle. Now where is secant negative? Secant will be negative in either quadrant 2 or quadrant 3. Now before we go ahead and use technology to find the arcsecant, we were going to do a little bit of analysis. In this case, I'm just going to draw out a coordinate system. Where is secant negative? Secant's going to be negative in quadrant 2 and quadrant 3. So we have these two angles. Now when we go to take the arcsecant, it will give us this angle right here. It's called theta 1. Okay? Now, we are also then going to need this angle right here. That is theta 2. Let's find a way of finding it. Well, let's call this angle here our reference angle for theta 1. That is theta prime. Now, if we look at this, theta prime is pi minus theta 1. Now, if we look at theta 2, it's going to be pi plus theta prime, right? Because the reference angle here is going to be the same as the reference angle down here. Why? Because it's the same value, -4. We can now plug in theta prime. So it's pi plus pi minus theta 1. So this winds up being 2 pi minus theta 1. So once we find our theta 1 using technology, we then will do 2 pi minus it to get our theta 2. Okay, here we are in our calculator. You always want to make sure that you're in the proper mode, right? We want radians. Now remember the equation was secant of theta is equal to -4. So I'm going to use secant of x is equal to -4 just to write that out. So this means that the inverse secant, so again we come over to trig, inverse secant of -4, -4 is equal to x, so we want this, so we hit enter, and we notice it's going to give us a value that looks like this. This is the exact value. This is not what we want. So if this is what you get, there are two ways to get around this. You can either control enter, which will give us an approximation, or we can come in and put a decimal after the -4 and then just hit enter normally, also gives an approximation. So for our first answer, we have approximately 1.823. All right, let's go up to 3 decimal places. Now what we want to do is we want to find the second solution. Now remember, this was done by 2 pi minus this first solution. And we always want to use an exact answer here, so 2 pi minus, and now all we have to do is hit control. Right here, this negative is answer. Hit enter, and that'll be our second solution. So about 4.460. And as we just saw then, theta would be the solution set of 1.823 and 4.460. Now let's go ahead and look at this one. Again, take note, we're only looking 0 to 2 pi. Now here it looks like it's in quadratic form. So what we can do is we can say let x be cosine of theta. Then this equation has the form x squared plus 3x minus 1 is equal to 0. And we know how to solve this. Can this be factored? It cannot, right? Factors of 1 when subtracted give 3, none exist. So we're going to have to use the quadratic equation. Right? That says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. This is negative 3 plus or minus the square root of 13 all over 2. Now, we have to remember that x is cosine. So this means that cosine of theta is negative 3 plus or minus the square root of 13 all over 2. But you also have to remember that the range of cosine is between -1 and 1. So we check to see if both of these values satisfy that. And in fact, they both don't. This will become cosine of theta is equal to negative 3 plus the square root of 13 over 2. Because negative 3 minus root 13 over 2 is less than negative 1. It falls outside of our domain. So theta here would be the inverse cosine of negative 3 plus root 13 all over 2. Now this represents a quadrant 1 angle. We want a quadrant 4 angle. So this is theta 1. Theta 2 would then be 2 pi minus theta 1. And they wanted exact answers, so we just leave them in this form. Now this is another quadratic example, and again, notice we only care about 0 to 2 pi. So if again we say, well, let x be sine theta this time, then we're going to have 2x squared minus 5x plus 3 is equal to 0. Now this can be factored. Right? This will factor. We have x, 2x, we'll put a 3 here, a 1 here, then we have 3x plus 2x, that is 5x. Higher one will take the plus, so that's going to be 2x plus 3, and then x. I'm sorry, they're both going to be minus, that's a plus sign. They both have the same sign. That equals 0. This means that x is either positive 1 or x is 3 halves. This means that sine of theta has to be 1, right? We can't have this case here because that is larger than 1. Sine of theta is equal to 1. That means theta is pi over 2, and that is the only solution for 0 to 2 pi. Now we want to solve this one. Again, for 0 to 2 pi. Now this is where it gets interesting. This is where we're going to start using identities. This is the identity, the difference identity, I should say, for cosine. This then says cosine of x minus 2x is equal to the square root of 3 over 2. So cosine of negative x is the square root of 3 over 2. But since cosine is even, we can say cosine of x is the square root of 3 over 2. Well, this has two solutions to it. Right? We have, again, look at a unit circle if necessary. We're going to have a quadrant 1 angle and a quadrant 4 angle. Quadrant 1 angle would be pi over 6. The quadrant 2 angle, the quadrant 4 angle would be 11 pi over 6. We now look at this one, and now notice that this did not give us a restricted domain. So here we're actually going to try and find every possible solution. So we have cosine of 2 theta is equal to cosine of theta. What we're looking for is to try and do this in terms of just cosine of theta. So double angle, there are 3 of them for cosine. Only one of them will be useful here. We're going to use the one that says cosine of 2 theta is 2 cosine squared of theta minus 1. Then we can write 2 cosine squared of theta minus cosine of theta minus 1 is equal to 0. Now this looks quadratic, so we can let x be cosine, and this will look like 2x squared minus x minus 1 is equal to 0. Now this one can be factored. We'll have a 2x here, we'll have an x here, we'll have a 1 and a 1, and the higher one will be negative, so we'll have 2x minus 1 times x plus 1 is equal to 0. So that means that x is a half, or x is negative 1. I'm sorry, positive, negative 1. That's right. The higher one takes, I'm sorry, I flipped these around. This should have been negative here. That should be, so that's going to flip these signs. That'll be negative a half or positive 1. Well, remember, x was cosine, so cosine of theta is negative a half, or cosine of theta is positive 1. Here we're going to have 3 solutions. Again, draw a unit circle for reference if needed. Cosine negative 1/2, that's going to take place in either quadrant 2 or quadrant 3, so that has 2 solutions. Then we have to add 2n pi to each one. Whereas cosine equal to 1, that would be right here on the x-axis. All right, let's tackle that one first. So theta 1 will be everything in the form of 2n pi for some integer n, right? So 0, 2 pi, 4 pi, so on and so forth, as well as the negatives. Now we need to tackle this piece right here. Let's look at the quadrant 2 angle first. So what quadrant 2 angle gives us cosine as negative 1/2? Well, that would be 2 pi over 3. Like so. And finally, we'll look at that quadrant 3 angle. That would be 4 pi over 3, then plus 2n pi, such that n is an integer. And we now go ahead and look at this. And again, we notice that we're going to have restricted domain of 2 pi. 3 cosine theta plus 3 equals 2 sine squared. Now again, the idea is we do not want that sine squared there. We want to try and write it in terms of cosines. In this case, the Pythagorean identity is going to be helpful. So we can write this as 3 cosine of theta plus 3 is equal to 2 times then 1 minus cosine squared. If we distribute that 2 through, we get 2 minus 2 cosine squared. This tells us that 2 cosine squared plus 3 cosine of theta, and that'll be 3 minus 2, which is plus 1, is equal to 0. This has the form of 2x squared plus 3x plus 1 is equal to 0. Now this can be factored. Put a 2x here, an x here, then they'll both be 1s, and they'll both be plus. Which means that x is negative 1/2, or x is negative 1. But since x was cosine, we have cos theta negative 1/2, or cosine of theta is minus 1. Again, if we draw a reference unit circle, negative 1/2 will be one of these two over here. Negative 1 will then be this point right here. So theta 1 would be pi. Theta 2 would be 2 pi over 3, and theta 3 would be 4 pi over 3. And finally, we have this example. Cosine of 2x is equal to 1/2, and again, we're only looking 0 to 2 pi. Now, let's draw reference unit circle. 1/2 will be either quadrant 1 or 4, whereas cosine equal to 1/2 in quadrant 1, that would be pi over 3, which means 2x is pi over 3, or 2x is, where is cosine 1/2 in quadrant 4, that is 5 pi over 3. Now, this one will lead us to x being pi over 6. This one here would lead us to x being 5 pi over 6. However, we're not done. Remember, the period for cosine is pi, but we want 0, or I'm sorry, the period for cosine of 2x is pi. We want 0 to 2 pi, so we're actually looking at 2 full revolutions. This is only through 1 rotation. So we have to add pi to both of these. So we'll get x1 is pi over 6, x2 is 5 pi over 6, x3 would be pi over 6 plus pi, which is 7 pi over 6, and x4 would be 5 pi over 6 plus pi, and that is 11 pi over 6. That concludes our video on trigonometric equations. To solve trigonometric equations, remember, you are going to need identities, so you need to use proper identities. You need to know the properties of trigonometric functions, right? So you need to know that the period of cosine is 2 pi, right? But if you're multiplying the angle by something, as in here, you have to divide the period by that constant. So for this example, it was 2 pi divided by 2, which was pi. Remember the reference unit circle, so if you do, always draw a unit circle as reference, and pay close attention to if there is a restricted domain. Usually that restricted domain would be 0 to 2 pi, and it will always be stated in the problem. If it is not stated in the problem, as was in this example here, then that means that you must list all of your possible solutions. So whatever you get as a solution, add 2n pi to it. That gives you all the possible solutions. This also ends this series on pre-calculus.